All right, here goes. This is an introduction to chapter 22, the last chapter of unit 5. And we're going to use the discussion of, you can see here, mobile quarterbacks being more prone to injury than pocket quarterbacks. Now, I took these numbers from an article that was on slate.com from their sports section, and I strongly recommend checking that out. The articles in there are very good. There's a very interesting one in there about the statisticians in pro basketball and how the statistics community developed around pro basketball and how it differed from that around baseball. Very interesting article, and I strongly recommend it, especially if you're interested in basketball stats. So I modified the statistics that were in the article about this injury issue so that we could use it in this example. So we have 11 out of 55 mobile QBs getting injured, serious injury, while 48 out of 269 pocket quarterbacks get serious injury. And so our question is, that we're going to answer with a hypothesis test, are mobile quarterbacks more prone to injury than pocket quarterbacks? Now, we're going to have to make some assumptions here, and these are kind of a stretch. Assume that the individual quarterbacks are independent of each other, and this total sample is randomly drawn from the population of quarterbacks. We're going to assume it's less than 10% of the population. Now, there's another consideration. Once you are comparing two populations, in this case, we're comparing the populations of mobile and pocket quarterbacks, two separate populations, you must say something about the issue of whether or not these populations are independent of each other. And so for the sake of this exercise, we're going to state that pocket quarterbacks are independent of mobile quarterbacks, even though a number of pocket quarterbacks eventually, mobile quarterbacks become pocket. I don't think it goes the other way. Quarterbacks get older, and then they stop running around. All right. Now we have to do the, we got to do NP and NQ are both greater than 10 for both samples. So 11 and 44 are both greater than 10, and 48 and 220 are both greater than 10. This is NP and NQ right here for the mobile quarterbacks. And then the other two numbers are, so here we have NP and NQ for mobile, and then NP and NQ for pocket quarterbacks. And you see they're both greater than 10. Barely, but that's one of the reasons why I had, one of the ways I had to adjust the numbers. Okay, so we're going to say that we believe the samples represent the population of quarterbacks, and that p hat delta, we're going to call p hat delta the difference between the two sample proportions, and has a sampling distribution of approximately normal. Now, this is the sampling distribution that we're going to use to make a confidence interval. So the first thing, we're just going to go through the exercise of making a confidence interval. Now let's look at this for a minute. Now we're saying we have two independent, and we can definitely call them random variables. Now if you recall, the standard deviation when you take two random variables together is the square root of the sum of the variances. Well, the variance, since the standard deviation of the first sample is the square root of p hat q hat over n, the variance is simply p hat q hat over n. In other words, the square root squared. And the same for the second variance. So this is the variance for the sample of the mobile quarterbacks, and this is the variance right here. This is mobile, and then this is pocket. Let me put a p here. Okay, not much of a P. Anyway, mobile and then P. All right, so, and then P hat delta is P hat 1 minus P hat 2. Now I'm doing 1 minus 2, so I'm dealing with a positive number because, as you can see down here, the P hat for mobile quarterbacks. Now notice I didn't, this is mobile. Let me label this. Mobile QBs. And then this is p hat sub 2 are pocket QBs. And the p hat for that is a little bit less. Okay, and so then we're calculating p hat delta, which is simply the difference, 0.2 minus 0.178, which is 0.022. So the standard error of p hat delta is the thing we just talked about, this computation right here. Okay, so it's going to be the square root of 0.2 times 0.8 over 55 plus 0.178 times 0.28 over 269. P hat sub 1 times Q hat sub 1 over N sub 1 plus P hat sub 2 Q hat sub 2 over N sub 2. Okay, and so the standard error is approximately 0.0576. All right, so continuing on here, the confidence interval, it's no different, is going to equal p hat delta, the difference of the two p hats, plus or minus z star, and we're going to do a 95%, so z star equals 1.96, times the standard error. So it's 0.022 plus minus 1.96 times 0.05876. And as you can see, this is 0.0932, comma 0.1372. So here's my conclusion. We are 95% certain that the true difference between the proportion of mobile quarterbacks who get seriously injured and pocket quarterbacks is between 0.0932 and 0.1372. Now, we haven't stated the hypotheses yet. Let's go down here. Oh, and here's the interpretation of the level of confidence. 95% of all similar samples yield a confidence interval that contains the true difference between the injury rates of mobile and pocket quarterbacks. All right. Now, I'm going to go down here. I didn't state the hypotheses. Let's have them right here. So the null hypothesis would be, it's always going to be when you're comparing two proportions, it's going to be that there's no difference between them. They're the same. That's, doesn't make any difference if you're mobile or you're a pocket quarterback. You're going to get your chance of getting a serious injury are about the same. But the question we asked was, are mobile quarterbacks more prone to injury? And since the difference is mobile minus pocket, then the alternative hypothesis is p hat delta is, p sub delta, that is the difference in the two populations, is that greater than 0. Okay? Now we go back, here's our confidence interval. Since 0 is in the confidence interval, we failed to reject the null hypothesis. There is no evidence of a difference in the injury rates of mobile and pocket quarterbacks. In other words, since 0 is in the interval, it could be that there is no difference. There's certainly no evidence that the rate is greater, at least not from this sample, of the injury rate's greater for mobile versus pocket quarterbacks. All right. Let's see. All right, so now let's talk about doing this test with a p-value. So what are we going to have here? We still have p hat delta, and we have the same presupposition, so we don't have to do those over again. But and so far, we really haven't had anything new. The only thing that's been new, actually there's been nothing new, because we've dealt with random variables, either adding them or subtracting them, and computing the standard deviation as the square root of the sum of the variances. And there's nothing different about how we did the confidence interval. But here we have a new idea. Now, we're going to find a p-value, and the p-value assumes the truth of the null hypothesis, h sub 0, which is that there's no difference. Okay? Well, if there's no difference, then what we're going to do, we're going to do this thing with our numbers, with our samples, called pooling. That is, we're going to take x sub 1 and x sub 2 and add them together, and n sub 1 and n sub 2 and add them together, and get this totally different statistic, 0.1821. That is called p hat pooled. And this is based on the idea that if there's no difference between them, if there's no difference in the injury rates, then we can take the numbers from the samples and combine them and make one sample. And we will use this statistic, p hat pooled, to construct the standard deviation for p hat. So the standard deviation for p hat pooled, I'm sorry, this should say p hat delta, because that hasn't changed. We're still doing it on p hat delta. Is p hat pooled q hat pooled over n sub 1 plus p hat pooled q hat pooled over n sub 2. And so the numerator is going to be the same. The only thing that's different is the denominators. And so we end up with the standard deviation for p hat pooled of 0.5711. And so, now I don't say this here, but we're going to say p hat pooled, I'm sorry, p hat delta has a sampling distribution. I should have typed this in. Sorry, I did not. Of approximately normal. Now, 0, 0.1821. In other words, the center is, it's based on h sub 0. H sub 0 is at p hat delta equals 0. Okay? So we compute the z-score, which is p hat delta minus p sub 0, which is simply 0.022 minus 0, divided by the standard deviation for p hat delta, which is Got to stop here. Something's wrong. Something's wrong. Something's wrong. Okay, I had a couple of typos on here. Sorry about that. Okay, I had 0.5711 here. It's 0.0571. Everything else I had was correct. But anyway. Okay, so the standard deviation for p hat, let's see, we're calculating the z-score using a standard deviation for p hat delta, and we come up with a z-score. We got 0.022. So 0.022 minus 0 divided by 0.05711 is approximately equal to 0.38521. So the p-value, the probability that z is greater than or equal to 0.38521, is approximately equal to 0.35. Now alpha is 0.025, so the p-value is greater than alpha. Not significant. Conclusion: since the p-value of a difference of 0.022 occurring randomly between the injury rates of mobile and pocket quarterbacks, assuming there is no difference, is 0.35, we failed to reject the null hypothesis. There is no evidence that there is a difference between the injury rates of the two types of quarterbacks. All right, now let's go over how to do both of these things. Let me go up to where we got all of our data here. Let's do this. Let's do both the confidence interval and the standard deviation and the p-value computation on the calculator. So I'm going to closing tools, put this in. I'm going to use the calculator. So I'm going to clear. Okay, so we go to stat and tests, and let's do the two proportion z-test, number 6. And you can see I got my numbers in here, 11 and 55. x sub 1 and n sub 1. Okay, x sub 2 and n sub 2. Okay, my null hypothesis is that it's greater than, that p sub 1 is greater than p sub 2. P sub 1 is greater than p sub 2, right? P sub 1 is greater than p sub 2. So we go down, we arrow down, and we hit calculate. Okay, now my z-score is slightly different because I probably did some rounding. My p-value is essentially the same, 0.35. Okay, and it gives me my p-values, and here is p hat pooled, right here. Okay, p hat pooled, and then underneath it are the n's. Okay, so it gives you, you got everything here you could possibly want, including p hat pooled. All right, now let's look at how to do this with a confidence interval. So we'll do stat and tests. Now, if we go to the confidence interval, it will inherit all of the numbers that we just put in. So a 2-sample z interval, let's see, 2-proportion z interval, hit enter. There it is, everything we wanted. Confidence level 0.95, that's what we used, and that's what gave us an alpha of 0.025, because it's a one-tailed test. And we hit calculate, and there is basically the same confidence interval that I got. Okay, and that's it. So this is the essence of chapter 22. Use this, go in, do some homework problems, and get yourself some confidence in using these techniques. And have some fun today.